Let's take a look at a few more examples. In example 2, the claim is that less than 24% of internet users pay bills online. So for question A here, because the claim is talking about the percent of internet users, I know that I'm dealing with a population proportion. So the notation that I'm going to use in my hypotheses is going to be some p-value. Now, I'm going to go ahead and translate this original claim into symbols by rewriting it as P is less than 0.24, and keep track that this is the original claim that we are trying to do a hypothesis test on. So original claim. Okay, let's take a look at this original claim. Notice that this original claim contains the less than sign, meaning it does not contain equality. So if the original claim does not have the equal sign in it, it immediately becomes the alternative hypothesis. So for part B, I'm going to write down that original claim as the alternative hypothesis. Okay, and then again, keep track that this is the original claim. This will be really important when it comes to writing your conclusion. Okay, so how do I write the null hypothesis? Once again, we take a look at the original claim and we ask ourselves, what if this is not true? What if the proportion of internet users who pay bills online is not less than 0.24? Then what are the alternatives? Well, the alternative is that that proportion, it could be greater than 24%, so greater than 0.20, or it can simply be equal to 0.24. It could actually be 24%. And so when we take a look at the alternative, you choose the alternative statement that contains the equal sign, and that always becomes the null hypothesis. So again, the null hypothesis always contains the equal sign. It always contains equality. So once again, we have just written the null and alternative hypothesis using the proper symbols. And then for question C, to determine what type of test we have, you always look at the alternative hypothesis and then look at the symbol. So because the alternative hypothesis contains the less than sign, this means that we have a one-tail, left-tail test. So left tail test. And again, when you start looking at your results, you're going to look at the sampling distribution for sample proportions, and left tail means that your critical region is going to lie all on the left tail of your distribution. Let's look at another example. In example 3, we're told that according to a study that was published in March of 2006, the mean length of a phone call on a cell phone was 3.25 minutes, but a researcher believes that the mean length of calls has increased since then. Okay, so the first thing we're going to do here is make sure we understand that we're dealing with a population mean. So how do I know that I'm dealing with a population mean? It's because we're told that we're looking at the mean length of a phone call. So the notation that we're going to use here to represent a population mean is the Greek letter mu. Now for question B, let's figure out what the null and alternative hypotheses are going to be. So I'm going to go back to the claim here, and I'm going to write it down using symbols. So we're told here that the mean length of a phone call was 3.25, but the researcher believes that the mean length of a call has increased since then. So that means that this researcher wants to test his belief here. So that means that we're going to test the claim that mu is actually greater than 3.25 minutes. And then I'm going to keep track that this is the original claim that this researcher is trying to test to see if that's true or not. Okay, so again, because this original claim contains a greater than symbol, so it does not contain equality, that automatically becomes the alternative hypothesis. Okay, so I'm going to still keep track that this is my original claim. Right, and then we have to ask ourselves, okay, how do we write the null hypothesis? So once again, you go through the process and you say, well, what if this statement is not true? So what if mu is not greater than 3.25? What are the alternatives? So if mu is not greater than 3.25 minutes, then that means that it could be less than 3.25 minutes, or the mean can actually equal 3.25 minutes. So we always take the statement that contains the equal sign, and that becomes the null hypothesis. So the null hypothesis is that the mean value is 3.25 minutes. So once again, we have just written the null and alternative hypotheses using the correct symbols and the correct notations. Okay, let's take a look at question C. How do we know if we have a one-tailed test or a two-tailed test? The answer to that question is you look at the symbol in the alternative hypothesis. So in the alternative hypothesis, because the sign contains the greater than symbol, this means that we have a right tail test. So it's going to be a one tail test, but on the right tail. So right tail test. And then when you start taking a look at your results, you're going to be looking at the sampling distribution for sample means. And right tail means that your critical region is going to lie all on the right tail of that distribution. Let's practice one more example. In example 4, a company claims that the percentage of men they hire is at most 60%. So first, let's make sure we understand that we're dealing with a population proportion, P, where the proportion of interest here is the percentage of men that this company hires. So looking at the original claim, I'm going to rewrite it using symbols. A company claims that the percentage they hire is, okay, so those words at most 60%, you kind of have to pause for a second here and think about what that means. So at most means that they get paid, at most means that they hire at least 60%, okay, or less. So P is equal to or less than 60% or 0.60. And this is the original claim. Now, notice that this is the first time where we see an example where the original claim contains the less than or equal sign. So this is not a mutually exclusive statement. So what we have to do is we have to break this down into two mutually exclusive statements, P less than 0.60, okay, or P is equal to 0.60. And again, this is still the original claim. So what do we do in this situation? We always take the statement that contains the equal sign, and that automatically becomes the null hypothesis. So I'm going to write this down as the null hypothesis, P equals 0.60, and keep track that this is the original claim. Again, keeping track of the original claim will help you later on when you write your conclusion. So then what is the alternative? Okay, how do we write the alternative in this situation? So looking at the original claim, P is either less than 0.60 or P is equal to 0.60. So what is the alternative if both of these statements are not true? So if P is not less than 0.60 and P is not equal to 0.60, then the only alternative is that P is going to be greater than 0.60. So then this becomes the alternative hypothesis, P greater than 0.60. And so now that we have written down the null and alternative hypotheses using the correct notation and symbols, let's determine whether this is going to be a one-tailed test or a two-tailed test. So again, looking at the alternative hypothesis, because the alternative hypothesis contains the greater than symbol, this means that we are going to have a one-tail right tail test. So this is going to be a right tail test, meaning that when we take a look at the sample distribution or sampling distribution for sample proportions, our critical region is going to lie all in the right tail of the distribution. So just to recap here off on the side, important thing to remember about the null hypothesis is the null hypothesis is always going to contain the equality sign, the equal sign, and your alternative hypothesis is either going to contain the not equal sign or the less than sign or the greater than sign, okay? So we never ever use less than or equal to or greater than or equal to in our null hypothesis or our alternative hypothesis. So please keep that in the back of your mind.